Hello everyone, my name is David, and for this last video of our series on the slow growth model, we're going to be discussing what is the golden rule savings rate, what does it mean, and how do we find it. So, the golden rule savings is, the definition of it is essentially the level of savings needed to maximize consumption in the steady state. That's the definition of it. So, using these same exact parameters as before, right? We haven't changed those. We're going to need to we're going to want to maximize our consumption function. And after we put in all these values, we're going to try to find what alpha is when we maximize this function. So recall that our consumption function was 1 minus sigma to the times output, right? But we can't work with that at the moment. We have to modify it a little. Also remember that output is A times K to the alpha. So, rewriting these together, consumption is equal to 1 minus sigma times A K to the alpha. But once again, remember that since this is going to be in the steady state, this K is going to be exactly equal to K in the steady state, which we know the function for that is sigma times A over N plus D, all of that to the 1 over 1 minus alpha. So let's plug that in right there. And so the final function that we're going to have is that consumption in the steady state is going to be equal to 1 minus sigma A sigma A over N plus D, all of that to the alpha over 1 minus alpha, because we can't forget that there's an alpha here. All right, and so that's right there is going to be our consumption function as a function of all the parameters we're given. So with that, let's try to maximize this consumption function. So maximize consumption. That's going to be 1 minus sigma. That's the one thing we don't know. That's what we're going to try to solve for. Is that times, let's also plug in our values. So A is 100. Sigma is the unknown. Times 100 over 0 plus 1. All of that to the 1/2 over 1 minus 1/2. So that whole thing is just going to be 1, right? And so, before we start maximizing, let's simplify this a little. This can be rewritten as consumption is equal to 1 minus sigma times 100 times, since this is 1, sigma times 100. Once again, like that. So let's keep simplifying. SS is equal to 1 minus sigma times 10,000 times sigma. Okay? So, after that, let's distribute both sides here. And we'll get that capital in the steady state is 10,000 minus 10,000 sigma. But of course, we still have this last sigma right there. So, simplifying one step further, we have that 10,000 sigma minus 10,000 sigma squared is going to be our consumption in the steady state. Well, now that we've simplified it to the best possible form, now we can maximize this function. And so, let's take the derivative of this function. Let's take the derivative of consumption with respect to sigma. And what that's going to be is, this essentially disappears. So we have 10,000 minus, the 2 comes down, 20,000 sigma. To know that it's at a maximum, we set it equal to 0. And from there, we just solve algebraically. Let's subtract 20,000 sigma from both sides. 20k sigma. And so 10,000 is equal to 20,000 times sigma. Divide both sides by the 20,000. And so we find that sigma, the golden rule sigma, is equal to just 1/2. There you go. This level of savings rate will be the level that maximizes consumption in the steady state. And that's that. Thank you for your time. If you have any more questions, please see your professor or come into the ASU Tutoring Center. Thank you very much.